Okay, welcome back from spring break, and welcome to day 3 of online learning with Dr. Turbush. Okay, so the notes that I provided for today's class actually have a warm-up. So I expect you to write that warm-up in your regular warm-up notes. You don't have to do it right now, but you should do it, okay? Because at some point, I'm gonna probably have you either turn them in electronically, or if we meet face-to-face, collect them physically. Now, take a look at the warm-up question. I really want you to actually take your calculator and try to take the minus log of 2.34 times 10 to the minus 12. Do that. I'm going to stop for a moment and wait for you. Now, you should have obtained the number 13.631. Now, you actually had more digits than that, but I rounded it to 0.631. Why? Well, logs have special rules for sig figs. Not my rule, it's a log rule. That rule is also explained in the bottom of page 573 in your textbook. So, for sig figs, for logs, all the digits after the decimal point count, none of the digits before the decimal point count. So for instance, 13.00, that has 2 sig figs. 5.367, that has 3 sig figs. 1.001, that has 3 sig figs. Now these are different. These are pH values. So each one of these is a log base 10 value. Okay. Now, moving along. Okay, so what is pH? Well, pH is a way to quantitatively express the concentration of hydrogen ions in an aqueous solution. Okay, it's a log base 10 scale, and like I said, logs have special rules for sig figs. Each unit on the log scale, on a pH scale, differs from the closest unit by a factor of 10. So the log scale goes from, pH scale goes from 0 to 14, all right? So that's 14 orders of magnitude over which the concentration can vary. This is why we don't use a linear scale, because you can't graph that. But if you convert them to minus logs, you go from basically 0 to 14, and you can graph that on a piece of paper. Now, what do pH values mean? If you have a pH of 7, it is considered a neutral pH. As you're going to see, that's the minus log of the hydrogen ion concentration in just normal water. It self-ionizes, as you've heard before. All right, and the concentration is 1 times 10 to the minus 7 molar. Minus log of that is 7. So that's considered a neutral solution. Now, if the pH has a value less than 7, it is considered an acidic solution. So the concentration of hydrogen ions will be greater than 1 times 10 to the minus 7. If the pH is greater than 7, it is considered a basic solution, and the hydrogen ion concentration will be less than 1 times 10 to the minus 7. We already know from KW that when we multiply the hydrogen ion concentration versus the hydroxide ion concentration, we always end up with 1 times 10 to the minus 14. Jalen and Lily, will you guys please stop talking? It's really getting annoying. Okay, moving on. So the slide after that talks about how we calculate pH. Basically, there's a whole bunch of different formulas on the next 4 pages. It's these 4 right here. Now, let's think about how we actually can do this. I'm actually going to try to show on my calculator, hopefully I can get close enough that you can see it, how to do this. So for instance, if we want to take the value 0.001 molar of hydrogen ions, how in the world can we find the pH value, and what buttons do we push? Okay, so let's put it up here. First we go minus log, and then we put 0.001 and hit enter. Oh my goodness, the value is 3. Hopefully you can see that on there. Okay? That's actually what it should be. Now the question is it 3? Well, really the value that we started with, 0.001, was not a log value, it's a regular value. It had 1 sig fig. So actually it would be 3.0. Now, you do exactly the same button pushing if you were going to find the pOH, and I'll explain that in a minute. Now, once you know pH of a solution, pH given by this equation, you can also use this equation to find the hydrogen ion concentration if you have the pH. So again, it's just a matter of plugging things in. Like I said, the 4 slides just give examples of how to do it. Now pOH, like I said, is equal to minus log of the hydrogen hydroxide ion concentration. So we have another way of actually kind of looking at things. pH and pOH are sort of like the yin and yang. One goes up, one goes down, etc. We can also, if we have the pOH, we can calculate the hydroxide ion concentration. Now, what we want to do is take a quick look at an example. But first, I want you to think about something. This is Kw, right? Well, couldn't we substitute for some of these values? So what if we solve for H here and then plug concentration at H? Let me pause for a minute. Okay, all we have to do is substitute the values, all right? So what we want to do is take this value, and let's take minus log of both sides. Well, minus log of this is a value of 14. Over here, you have to remember how logs work. They're multiplied together, but when you take the minus log of the entire thing, they're going to be added. So you get minus log of the hydrogen ion concentration plus minus log of the hydroxide ion concentration. And now you can actually substitute things. Take a look. Isn't this pH? So you can put pH. Sorry, Molly. Don't worry, you'll get tossed at somebody again soon. And you can substitute for this pOH, and that'll give you 14. Now, there's a lot of equations, all right? You're going to be given all the equations you need in terms of when you're doing worksheets and so forth. We'll probably do an online quiz at some point as well. So don't worry, you'll be given the equations, you'll have them. As far as homework goes, you'll be able to just look them up if I didn't give them to you anyway. And if we were going to do an assessment, like if we ever get back to class, I would actually give them to you. Now, let's take a look at an example problem. Martin, wake up. Boy, get to this. Okay, let's see. If the concentration of barium hydroxide is 3.15 times 10 to the minus 5. Now we're basically down to the last slide. We're asked, what is the pH of the solution? So concentration of barium hydroxide is 3.15 times 10 to the minus, is it minus 5? Minus 5 molar. Okay, so first thing we got to do is actually find the hydroxide ion concentration. We have the concentration of the compound, but it's pretty easy because there's 2 hydroxides per compound, so all we need to do is multiply it by 2. So 2 times that value is 6.30 times 10 to the minus 5 molar. Now remember, this is concentration of hydroxide. If we took the pOH value of this, well, there's more than one way to do this. Let's do it this way first. We can use 1 times 10 to the minus 14. We can use Kw equals OH minus times H plus, and solve. All we got to do is plug this in here. If we plug that in there and solve it, then we'll get the hydrogen ion concentration. And the hydrogen ion concentration from that calculation is going to be 1.587 times 10 to the minus 10. Now, if we need to find the pH, all we have to do is take minus log of that, minus log 1.587 times 10 to the minus 10. And so our pH value is going to end up being 9.799 with the correct sig figs. Now there is another way to do this, all right? We also could have, from here, decided to do it differently. But you're going to get the same answer, okay? What we could have done is taken minus log of both sides. If we take minus log of both sides, this is POH. Okay, and then we can actually find the POH value. Now, let me, give me 1 sec. Pause. Okay, so I took minus log 6.30, and then I used second EE, change sign, and 5, so I have the right value. You hit enter, and you get 4.201. Okay, that's a POH value. Wanted to find the pH value. 14 equals pH plus 4.201, and you subtract that from both sides, and guess what you're going to get? 9.799 equals the pH. So there's more than one way to actually solve this problem. All you need to be able to do is figure out one way. You don't have a hard worksheet this time. It's a very simple worksheet, just dealing with powers of 10 and a little bit of pH explanations. The next worksheet will be a little bit harder, okay? So that's it for this.